This is a quick little video on analysis of variance. Analysis of variance, you're testing for the equality of several means. By several, I mean more than two. So here's the research question that students came up with is, which drive-through joint is fastest at lunchtime? And the research hypothesis is that there is no difference in the average service time. Because it's more than two groups, this screams analysis of variance. In StatCrunch, to do analysis variance, you hit stat, then ANOVA. ANOVA is another way of saying analysis of variance, and one way. And note that it's a one-way ANOVA because you have one independent variable. If you had two, you'd use the two-way ANOVA option, but we only have one independent variable, and that's the restaurant. And we have three restaurants: McDonald's, Sonic, and Taco Bell. And then note the warning. The computer does the calculations. At this point, the actual doing it by hand is it's about as much fun as hitting your face against the wall. So let the computer do the calculations. You need to interpret the results correctly. So pay close attention to that. So here's example A. McDonald's, Sonic, and Taco Bell. Those numbers are the service times in seconds for the experiment that was set up. And the question is the average for McDonald's, and that's population average for McDonald's, different than that for Sonic and different than that for Taco Bell? And again, I do need to emphasize is fundamentally, we're comparing the population means, even though it looks as though all we're doing is comparing the sample means. So, in order to do this, let's throw it into StatCrunch. And here we are. Call variable 1, we'll call that McDonald's. Variable 2 we'll call Sonic. Variable 3 we'll call Taco Bell. And the thing is, you really do need to put the data in because there's no quote with summary option. The time for McDonald's, these are from the example. And finally for Taco Bell. Now to perform that analysis of variance, again it's under stat because we're doing statistics, ANOVA and one way. And now we want to compare selected columns, and the columns we want to compare we want to get over here on the right side, so we just click on them on the left, and they're written over here, and then calculate. And this is what pops up. The first table gives you the column names, the sample size within the column, the sample mean, the sample standard deviation, and the sample standard error, which is standard deviation divided by the square root of n. That's descriptive statistics, not really that interesting, or at least I don't think so. The second table is what's interesting. Second table is the ANOVA table. The first is the source. The second column is the degrees of freedom. Notice that there are three groups. 3 minus 1 is 2. The degrees of freedom for treatment will be 2. Notice there are 12 time measurements. 12 minus 1 is 11. That's the degrees of freedom total. And 11 minus 2 is 9. That's the degrees of freedom, quote, error. SS is sum of squares. MS is mean squares. Mean squares is a type of variance. FStat is mean square for treatment divided by mean square for error. FStat is our test statistic. It follows an F distribution. The book, chapter 14, section 1, covers what the distribution looks like. And there's the p-value. We interpret the p-value as we always do. Since p is less than alpha, we reject the null hypothesis. We conclude that not all the means are equal. In other words, one is different, at least one is different from the others, which is kind of boring because we just concluded that at least one's different. mean, fundamentally, we really do care about which is fastest, but you're going to have to wait for the next one, the next mini lecture, to find out how to test for which is fastest. So that's the end of this example. Now I want to do one more example, mainly because it shows how to load data into StatCrunch from the book. And we're going to do problem 13.1.16. So turn to section 13.1 and look at problem 16. While you do that, I'm going to delete these three columns. We won't need them anymore. Edit, columns, delete. It asks which columns. I'm going to get rid of all of them. Delete, and they're gone. Now again, problem 13, so I'm going to click over here on chapter 13, 1.16. There we go. Click on that, and voila, data is automatically in. And this question actually is asking, do births happen equally across all 5 days of the work week? So again, here we go. Stat, ANOVA, one way. And again, one way because there's one independent variable. That one independent variable is day of the week. We're going to compare selected columns. I'm going to select all 5 of these and calculate. Notice the first table is larger because now we have 5 days instead of 3 restaurants. The ANOVA table looks about the same though. Degrees of freedom treatment is 5 minus 1. 5 days minus 1 is 4. There's 40 measurements altogether. 40 minus 1 is 39. And 39 minus 4 is 35. Sum of squares, mean squares. The test statistic is F. It's 9.8. The p-value is less than 0.0001. And what that means is, since p is less than alpha, we reject the null hypothesis. We conclude that births happen not equally across all 5 days, but at least one is different from the rest. Again, we don't know which one, and it might be interesting to find out which one, but that'll wait for the next mini lecture. So hopefully that was helpful. Have a good day.